Okay, so today we'll be doing Euclidean geometry. So before we start, I want us to check this phrase. I can call it a phrase. It's called Dr. Cape Town L. So we just added an L here. So it's Dr. Cape Town. So what's gonna happen here? D stand for diameter, R stand for radius, then C cyclic quad, P parallel lines, T tangent and triangles, and L we're talking about the line drawn from center to the midpoint chord. So I'm gonna start with diameter number one, which is a diameter. So whenever you do questions for Euclidean geometry, just write this down, then you check if you have a diameter first, if you have a radius, etc. So for this one, we're gonna start with what? With diameter. So let's draw a circle. So a diameter, it's a line from a circumference and it passes through the center. So let's call this A, B, C. So it's the line from the circumference, then it passes through the center to another circumference. So that's what we call that a diameter. So the theorem is angle subtended by a diameter it equals what? 90 degrees, or we call it a semicircle, angle on a semicircle. So what we know, we can check. We check by we go to the endpoint of that line. So the endpoint is here and here. And then we go up with that. The angle that is subtended there on the circumference, or the angle that is subtended by that diameter, but that one is on the circumference. So that angle is equals what? 90 degrees. So now we're going to say angle A equals 90 degrees. And reason you can say angle on a semicircle or angle subtended by a diameter. So I'm going to write angle on a semicircle. So that's it for diameter. Number two, we have a radius. So for radius, let's write it down. So we have a triangle that goes like this. So this is basically a theorem from grade 11. I think this is theorem 1. I think theorem 2, I mean. So this, it goes like this. Then let's say we have A, B, and C. Let's call this one angle O1 and angle 2, O1, O2. So for this one, we know that a radius is a line from center to the circumference. It's basically it's a half of diameter. So that's a radius. We're talking about the radius. So for this one, what we are going to see, we can check all the radius are the same. Even if we have millions of radius in on a triangle or on a circle, I mean, they will equal. They are equal. All of them are equal. So for this one, you can see that we have radius OB. It's a line from center to the circumference. Then OB, that's our first radius, equals what? The line again from center to the circumference, which is what? OC. So we can start there. But this theorem, what we are going to check, we are going to deal with angle at center twice angle at circumference. So how do we check that? We check it using this. We check arc BC. If you can check, you can see that this is an arc. So the angle that is subtended by arc BC on the center twice angle that is subtended by arc BC again on the circumference. So we check arc BC. Let's check the endpoints of arc BC. It's this one and this one. So if we go up with that arc BC, we can see that it's subtending what? Angle O1. Again, we go to the endpoints of that arc. We go up, we can see again that is subtending what? Angle A. So the angle that is subtended by that arc on the center is angle O1. So center is angle what? O1. Equals what? Twice angle that is subtended by the same arc on the circumference, which is angle A. So it's going to be 2 angle A. So now you can see what? Angle at center twice angle at circumference. You are done about what? About the radius, number 2. Now let's go to number 3. So number 3, we are talking about C, which is cyclic quad. So when we're talking about the cyclic, so now we are going to number 3, which is cyclic quad. So for cyclic quad, we have three of them, three reasons. We have same segment, we have opposite angle of a cyclic quad, complementary, then we go to exterior angle of cyclic quad. So number one, when we are talking about same segment, we check the arc again, just like a radius theorem. So we check the arc. We can see that we have arc what? Arc CD. So arc CD, if we check the endpoints of arc CD and then we go up with that arc, we can see that arc CD it's subtending what? Angle A. Again, we can see also that arc CD is also subtending what? Angle B. So now we can say that angle A equals what? Angle B. Then our reason what? Same segment. So same segment. So basically we're talking about a segment. So they are subtended by the same arc. So number two, again, we can also see that we have arc AB. So if you can check here, you have arc AB. Arc AB again is subtending what? So let me use another color for this one. So if you can check, arc AB, it's subtending what? You can check the endpoints of arc AB, then you go with it. You can see it's subtending what? Angle D. Again, you go with it and you can see that it's subtending angle C. So that is to tell you that angle C equals what? Angle D. Reason is what? The same reason, same sec. So we are done with the first one. So now we are going to what? To the second one. So the second one, we're talking about the opposite angle of cyclic quad, which add up to 180 degrees. So when we talk about the opposite angles, it's the angles that are opposite. So we're talking about these two angles and also these two angles. So you are going to say what? Angle A plus angle D2 equals what? 180 degrees. Then your reason is what? Opposite angles of a cyclic quad. Then again, you can see that angle B and angle C are opposite. So you're also going to do that. So angle B, okay. Angle B plus angle C equals what? 180 degrees. The same reason. Now we go to the third one. So I'm gonna use that circle there. So I'm gonna use the one that I drew. So if you can check here, we have an exterior angle of what? Of a cyclic quad. So when we're talking about the exterior angle of cyclic quad, exterior angle of cyclic quad equals the opposite interior angle of that cyclic quad. So if you can check, the interior angle we're talking about what? D2. What is the opposite of that D2? It's what? Angle A. So that is to say the exterior angle of cyclic quad equals the opposite of interior angle. So now we're going to say what? Angle D1 equals what? Angle A. The reason is what? Exterior angles of cyclic quad. We only have that one. So when you are asked to prove that this thing is a cyclic quad, you are going to apply these things. It's either you prove same segment, or you can prove opposite angle of cyclic quad, or you can prove what? Exterior angle of cyclic quad.